So today I'm going to talk about a new program that I wrote. Actually, it's based on another program that I wrote a long time ago. So this one is called thepainter2. I apologize for the lack of originality in the name, but it's basically an improvement over the previous version, which was called the Painter. So I put all the code on GitHub, and I will of course give you the link to it. And here, if you look at the README, I put quite a bit of explanation on how to compile the thing and how to link it, etc., etc. I did this on Linux, WSL2, so it's that subsystem on Windows. So it's very easy to compile, whether you do it on Windows using WSL2 or you can do it directly in on a Linux box. So yeah, I explained pretty much everything. It's pretty straightforward. So what does that thing do? What does the Painter 2 do for you? Well, it takes as input a photo and it creates what I think is a painterly rendering of that photo, akin to an oil painting that is kind of slightly loose, still very realistic. But the important thing, and this is what I really like to see, is that you get the feeling that it was painted with a brush that's very, very stiff, and you can see all the brush marks. And the way you can accomplish that is that you actually produce two images, not just one. You produce your regular stroke-based rendering output, which is just basically the colors, but you also produce a what's called a bump map or height map that actually shows the height of each brush stroke. You get the feeling that this was actually painted with a brush. Otherwise, it would be super flat, kind of look like pastel with no relief whatsoever. And what I wanted to say also is that this thing doesn't use AI whatsoever. First and foremost, because I have no idea how you would do this with AI. I'm not saying you cannot do it, but I mean, you can do this with regular old-fashioned computer vision state of mind. I mean, you don't need AI really to do this. This is kind of a classic problem. I've tried to use AI. I mean, like things like Leonardo and whatever else is out there. I mean, I tried a bunch of them, but I was not successful in doing what I'm showing here. That is, take a photo and make like an oil painting out of it, showing brush strokes. I tried that, but it doesn't really work with AI. So I mean, you can certainly try with AI, but as I said, I was not successful. So this methodology of using just classic computer vision stuff, I think works okay. So why not do it? Let's first see what it does. I'm going to go into my WSL. So that's my WSL, that's a terminal. And this is how it looks like. So you have common. So this is another repo I got that you need to download. You need this in order for this one to link. So you need common repo and the painter2 repo. So if I look into under common, it's just utilities, mostly to math utilities or stuff to input output images. So the painter2, all you have to do, so yeah, it's all the source code. Yeah, I'm just going to do a make clean. You do a make, it's going to compile. And you can compile either in debug mode or in release mode. I explained that in the README. Then you go into main. I'm going to do a make clean and just do a make. So that creates the executable. And then if you want to run test cases, you can just go into test. So here I put a bunch of them. And basically here I have images of various sizes. Some of them are 1280. So that's the longest side. It's mostly the width, that's 1280. I also have some 1920 pixel wide. And this one, the pixels, is a bit pretty big. It's like 4000 pixels. So let's look into maybe a couple of them. So let's start with this one. So what I'm going to do is I'm going to run it, but I'm going to run it in the debugger because I'm so used to doing that. So you just run it like so. Okay, so what's going to happen is it's going to read an input file, so you don't have to input anything else on the command line. Okay, so let's run. And you get some verbose on the terminal that tells you what it's doing. It doesn't take long or too long. Okay, so now I'm going to fire up GIMP. Okay, so let's look at the input. So the input is this. Okay, now first, this is the image I started with. So this is coming from Pixabay. And what you must do before you do anything else is to reduce the number of colors in your picture. So the way to do it in GIMP is that you go into image, mode, indexed. And here you convert, but here you may want to change that to, I think for this one I did, oops. For this one I did 16. You can do probably 30, 32, even 64. I would think that you can go up to 256, but you know, I usually do 16. So here I would do 16 or 32. I would do 16, convert. And that's what you get. Okay. So basically, if you go back into, so this is my input image. So it's the same one as before. So that's my input image called content_image.png. And let's load up the output from thepainter2. So you get two images. So you get this one. Okay. And you get what I call the bumpy map, which is actually a bump map. So this shows you all the brush strokes that were applied on the canvas. So what you do now is you want to combine the two. Okay, let's. So you go into filters, map, bump map. You click on that. This guy here, the question mark, and you double click on this one, the bumpy map. Double click, and you get this. So this is basically the final output from thepainter2. And now if you go to 100% magnification, this is what you get. So you get the brush strokes, but you also see the like the relief, the height of the brush stroke. So I think it looks reasonably good. I'm pretty picky about this, so if I'm happy about it, it means it's probably okay. Okay, so that's one example. Let's look at another example. Okay, so let's look at this one, like tulips. So that's this one is a 1920 pixel wide. Again, fire GIMP. And this one I already did it. Tulips. Okay, so this is my starting point. So that's my starting point. So that's the image from Pixabay, but I only use 16 colors, 16 or 32, I don't recall, but it's probably 16. Okay, so let's load up the output from the Painter2. So this one, and the bumpy T map. So this one. Okay, then you click on this one, and then you apply the bump map. Okay, so here it is. So let's zoom to 100%, and this is how it looks like. So you really get the texture of the brush stroke. I think it looks pretty good. And this is without any AI, by the way. Okay, looks pretty good. Would probably be improved, but I'm pretty happy with it. Okay, so now let's get out of here. And let's go into... Okay, so let's go into the README. Now, first I want to explain how it works. So let's go into my website, my blog. And as you can see, I was working on that in 2018, so that's been a long time. And this is when I did the first iteration of that exec called the painter. But this is what it's based on. So it's based on basically two papers. This is the first paper by Aaron Hertzman, painterly rendering with curved brush strokes of multiple sizes. By the way, those papers are in the repo on the docs. And the other paper is this one, an algorithm for automatic painterly rendering based on local source images approximation by Shireishi and Yamaguchi. But the basic idea is very simple. What you do is that you start from a blank canvas, and you just put layers on top of layers of brush strokes. So basically each layer considers a grid, a regular grid, a uniform grid, and for each grid cell you're going to put a brush stroke of the appropriate color, unless the canvas, I mean the color on the canvas for that grid cell is already okay. So this piece of code here shows the process. So for each brush radius in the code now, it's called like a layer. It's basically a layer, but it's the same idea. And here is applying a Gaussian blur. I don't do it. I just, for each layer I paint a layer. That's all I do. And you can see that in the code. The function is called paint canvas. So it's not called paint, but paint canvas, and the paint layer is actually called paint canvas layer. So that's the basic idea. And then the paint canvas layer, which he calls paint layer here, what you can see here is that is looping. So you have that for X and for Y. So it's a loop over all the grid cells. And then for each grid cell is basically choosing a color. And then if the error is greater than the threshold, it's going to make a brush stroke. So in my code, it's called, it's not called make stroke, it's called make brush stroke. And there's also a paint brush stroke. Okay, so now let's go into the repo and look at that help file or readme file, because as I explained before, the exec is looking for an input file, and the input file looks like this. Okay, so this first line is just your reference image. So it's your image coming from Pixabay or whatever, and you did not forget to reduce the number of colors. This is just it's basically a default starting canvas. It's either a white canvas, a medium gray canvas, or a black canvas. The bumpy T for the canvas, again, this is a height map or bump map, and it's simulating like a real canvas, like a real linen canvas. Okay, the 24 is basically the number of layers, and if you look at it, if you look at one, I can explain this one. So the 384 256 is basically the width and the height of each grid cell. So again, for each layer, you consider a grid, and this is the size of each grid cell. So 384 by 256. And basically that 256 should correspond to a brush width. So 256 here is the height of the grid cell, and that should correspond to the brush width. The 0, 0 is the offset, so you have an offset in the width direction, which is the x direction, and you have an offset in the height direction, which is the y direction. And the reason why I have this offset is because if you only put 0, 0, so meaning no offset, when you paint that layer, it will not cover the whole canvas. So you don't have full coverage. So to guarantee full coverage, instead of doing one layer, you have to do 4 of them with different offsets. And basically the offset, like if I look at this compared to that one, the only difference is the offset in the horizontal direction, the x direction. And I put that offset at 192, which happens to be half of this one, the grid cell width. And as you can see, I do the same thing on this one, but in the other direction. So I put a 128, which is 256 divided by 2. So 0, 128, and then you have the last offset, which is 192 and 128. So again, these 4, instead of just 1, it's for complete coverage of the canvas. Okay, so those 0808, this is the opacity strength and what I call the bumpy T strength. In just a few words, it's about the mixing. So when you have a stuff on your canvas and you put a brush and you apply a brush stroke on top of it, how do you mix the paint and the height? So if the strength is at the maximum, which is 1, then when you apply the brush stroke, you don't mix. You just use whatever you have for that brush stroke. But if the strength is lower, like 0.8, 0.5, whatever, you mix with what's already there. That's pretty much how it works in a nutshell. Okay, this one, the 10, this is the error threshold. So you need that threshold because you need to compare when you do a layer and when you're about to apply a brush stroke, you need to know if you should do it or not. So you need to compare the color that you're going to put in that grid cell with whatever is already there. So if the difference between the two colors are not much, you don't need to apply the brush stroke. This controls that threshold. So if you put a 10, it's very likely that it's going to apply the brush stroke. If you put like a 50, if the colors are close, it's probably not going to put the brush stroke. Finally, this is an index into the brushes. So if you go down, these are the brushes. So here I have 6 brushes, 6 different brushes, and they are pretty much the same, except that they have different sizes. So you have one that's called brush 256, there's another one 128, 64, 32, 16, and even 8. So basically, let's say you're looking at this one, this layer, the grid cell width is 96 and the grid cell height is 64, so you want to use the 64 brush, so index 2. So this is index 0, this is index 1, this is index 2, and this is indeed brush 064. And finally, this is the output, so you have your RGB image and you have your bump map or height map. Okay, so that covers pretty much everything I wanted to say, and I don't want to make the video too long. So if you have any questions, just put in a comment or ask on the GitHub platform. And that's about it. So I'll see you around. Bye.